Welcome to our brand new webinar series, Cloud Native Launchpad, designed to help you unlock the full potential of cloud native solutions. As cloud technology continues to evolve at a rapid pace, offering scalability, flexibility, and efficiency like never before, our webinar series is your gateway to mastering the art of cloud native development, deployment, and management. My name is Renu Bhatt, Program Lead for the Customer Enablement team here at Oracle. And joining us today for this webinar are two extremely talented, knowledgeable, experienced, and my favorite, Eli Schilling and Larry Bussley. And now I will hand it over to Eli.
Excellent. Thanks, Renu. Appreciate the opportunity to be here and looking forward to chatting with everybody. And thanks, Larry, for joining me. We are going to be talking about just kind of intro to building and running apps on OCI today. But before we get into that, let's just do a quick intro. So as Renu mentioned, my name is Eli Schilling. I started with OCI actually 2017. So I have been working with OCI and cloud for quite some time and really spending a lot of effort in energy in the cloud native and the DevOps space. So we're going to be kind of talking through some of those concepts over the course of the series, and I'll give a little bit more detail once we dive in. So Larry, how about a quick intro from you, sir?
Eli, I'm Larry Bussley. I'm a senior manager here at Oracle. I've been at Oracle going on 5 years, but I have a background in infrastructure, networking, pretty much anything that I can get my hands on when it comes to tech, or occasionally a slice of cake.
Yep. And there's Larry with his cake. It's pretty indicative of the fact that at OCI, we believe you get to have your cake and eat it too. I just wish I had a slice to munch on today during the session. Cool. All right, so just a really quick overview of the journey. This is a 6-part series. Of course, we're starting today with the introduction, and we are going to be exploring the world. So in December, we'll get into automation of everything with infrastructure as code. Then the next session will be managing code with a variety of tools and developer environments in the cloud. Session 4 is going to be Kubernetes management made easy with Oracle Container Engine for Kubernetes. Serverless apps and OCI functions will be session 5. And then we will climb to the end and defeat the big boss as we talk about building or enhancing your CI/CD architecture with OCI Devops. And just for fun, if anybody recognizes the map on the screen here, this is pulled from one of my favorite classic video games, borrowed rather. Throw a note in the chat to the hosts and panelists, and we're going to be potentially giving away some swag for the first person that guesses correctly. So adding a little fun there, bringing up the past. All right. So objectives, we're going to explore the AppDev ecosystem on OCI, take a look at some of the core capabilities, the flexible infrastructure. I want to spend just a minute talking about what's new in Oracle 23c database, just because it is so critical in some of the cloud native AppDev functions. And then we're going to do a little demo towards the end that's kind of a basic end-tier application, and we'll show some tips and tricks there if you're looking to get started. So without further ado, let's kind of kick things off with OCI in a nutshell.
That's not OCI in a nutshell. This is me in a nutshell.
Larry in a nutshell. All right. We're going to have some fun today. Wanted to start by kind of taking a step back, though, and thinking through as we're building and designing applications, what are the considerations, the requirements? There's a whole set of tools, requirements, capabilities that we are going to be factoring. Of course, starting with data. That's typically point number 1. What are we collecting? How are we storing, using, distributing, etc.? That leads us into some traditional applications like end-tier architecture deployed on virtual machines, moving into more of the cloud native space with some of the modern application development approaches, containerization, microservices, really intended to drive portability, scalability, and reliability of our application ecosystem. We will talk about low code just a little bit. It's sort of out of scope for this series, but I do want to mention it just briefly in case there's folks interested there. Moving up the stack, traditional and modern frameworks and languages. So we did ask about the variety of programming languages that are in use by folks on the session today, and it sounds like we've got some Java, some C#, a little bit of Python, some other I saw in there. Be curious what that might be. But making sure that we have the capability to satisfy all of the requirements of the applications and the languages we're using. Messaging, so sharing data between the applications. This is not just ETL between the databases, but being able to communicate, whether it's at the API level or some sort of intermediary solution, which could lead into a caching solution, whether it's a data grid or mechanisms to offload data retrieval to a faster front-end type, in-memory capability to deliver those results more quickly to the application. Security and governance, of course, is a critical factor. We want to make sure that our application is secure, that our footprint is protected in the cloud. And obviously, there's some of the operating capabilities, whether that's infrastructure as code, app automation, manageability, and of course, governance there as well.
It's a massive list of items there. The security piece. I want to hit that one again, because I think that's one that's not that should be talked about more. But security is very crucial along this journey, even when it's cloud native, because the product is protected cloud native. There are certain things that are taken care of there, but when you put your data in there, everything else, we still have to consider those pieces.
Absolutely, that's an excellent point, Larry. And we want to make sure that the security is designed in from ground zero. Essentially, it's a critical component across all of the ecosystem that we're going to be talking about today. So what does this look like in terms of application development with Oracle? We have kind of our same channels here, and we're just going to fill these in. So database, of course, we have a number of Oracle database services and support for a whole ecosystem of open source databases as well, whether it's MySQL, NoSQL, spatial databases, big data, high performance compute, making sure that all of those capabilities are available to the freedom of choice to the folks that are using OCI. In terms of traditional and cloud native, we're going to talk predominantly about kind of where we're starting today, the traditional, deploying to virtual machines, looking at different end-tier application architectures, but evolving as we go through this series into more of the cloud native approach with containers, serverless functions, and other solutions that enable us to build more distributed and sort of lightweight application architectures. Now, what do we mean in terms of framework and languages? I'm just going to draw these out here. And basically, this is to show whatever you're using, whatever you want to use. If you're Java, if you're building C# applications, Python, Ruby, if you're front-end developer with things like Angular and React, full support for all of those in OCI. And if you're integrating with the backend OCI services, we have software development kits for Java, Python, Node.js, Ruby, and Go, with hopefully some others to come not too far down the road. In terms of messaging, the Java Management Service, Kafka, of course. Alternatively, there's an OCI streaming service that is built on open source technology and fully Kafka compliant. From a caching perspective, we have, okay, my slides didn't get drawn properly. We'll come back to that. Coherence is an in-memory data grid, or there's a new Redis service that just recently released. I know Redis is fairly popular out there as a queuing mechanism. Front-end API management, API gateway for exposing as little as possible of your application to external services and users. We'll take a look at that in more detail in the serverless functions session down the road. And then, of course, from a DevOps perspective, all the different monitoring, observability and management, automation tools, whether you're scripting, whether you're using open source tools like Jenkins, third-party tools like GitLab, and Terraform or other infrastructure as code tools that are available in the marketplace. And I would be remiss if not to spend a moment just mentioning the disruptive technology. I know generative AI, of course, AI/ML is a pretty big topic of conversation in the industry today. So there's always considerations around how do we extend our applications, our app functionality to leverage some of these capabilities, whether it's using Gen AI to automatically populate various facets or components in our end user experience, whether you're using machine learning to develop models that streamline and simplify decision-making processes, and so on. But again, those technologies are readily available to integrate into your overall application ecosystem. Let's see, there's my OCI cache with Redis. All right.
It was a latency issue in the cache, so I had to clear the cache to refresh it.
I think it was. Maybe my internet's kind of slow today. All right, let's spend just a minute on core infrastructure now. As far as availability, it's critical when considering cloud to ensure that we have not only resources available in proximity to where we are working, where our customers might be, and also within various sovereign locations. When you think about data privacy, data sovereignty, you want to make sure that you can comply with any and all local laws. So that means not necessarily moving data out of places where it shouldn't be moved from. So another thing, Larry, you want to just tell us really quick about the Microsoft partnership? I think that's a pretty big capability as well, especially with, I think at last read, 98% of organizations running in cloud were developing some sort of multi-cloud strategy. That's pretty critical.
Yeah, so I think there's two functions. One function that we've already been doing for a while, which is the interconnect. So having the Azure interconnect has been beneficial, but the most recent announcement is actually having our hardware in Azure data centers. So having access to like Exadata hardware in Azure to be able to run what you're trying to run. So it's going to be a huge thing, especially when it comes to deploying on Azure. So you have access to our capabilities. If you're not looking to set up an Azure interconnect, it gives you another option, another possibility there. But it's still something today you can set up the Azure interconnect, and that's, that kind of goes into that multi-cloud strategy. It's not only Azure Interconnect, there's other ways of doing multi-cloud strategy when it comes to the infrastructure deployment here, and utilizing a lot of our tools, or if you're using Azure AD, or if you're using certain tools that your team's already trained on. So there's a lot of different capabilities there.
That's a good point, Larry. I think, leveraging the tools we're familiar with will not only help reduce the learning curve in terms of implementing or accelerating cloud adoption, but it also means more efficiencies for the business overall. So making sure that, again, that users have options to pick what's going to work best, what they're most familiar with, and enable them to deliver applications in the cloud as quickly and efficiently as possible. So I want to take just a quick look at the underlying architecture and kind of how we built the OCI cloud. Won't spend a whole lot of time here, but the one thing we've talked about a lot is the off-box virtualization, and this is one facet that gives us sort of two key components. One is isolation, so everything is isolated outside of the actual compute infrastructure that you're using. It also means that the overhead for virtualization and security controls in the compute ecosystem is handled outside of the resources that you would be leveraging, that you would be deploying. So there's no overhead, there's no noisy neighbor, there's no contention. When you provision something, you're getting 100% of the resources provisioned without potentially being impacted by others. The RDMA, the remote direct memory access cluster networking, I'm always impressed by how the team built this, especially. So if you're thinking about high performance compute, if you're working in the AI/ML space and the data science space and looking at building out GPU clusters, you'll see on the right side there, it's possible to create a single cluster with 32,768 GPUs. Now, I haven't done the math on that. I don't know if I want to know the answer to that, because GPUs are not the least expensive resource out there, anywhere you go. But the resource, the capability is available. And the benefit there is, if you work for a large organization that's looking to train massive large language models, it's not a matter of kicking off the training process and waiting days or weeks. It's more of a matter of how much infrastructure do you need to get that job done as quickly as possible, how much capacity. So the superclusters are going to help facilitate that. And then the last thing here, we'll dig into a little bit more about the flexible infrastructure. I like this one a lot as well, because we don't have to keep track of dozens, if not hundreds of different shapes. I don't have to know that there's memory shapes or storage shapes or compute shapes. I just pick a flexible shape and then I scale the resources that I need specifically based on my application requirements. So with a virtual machine, I pick the CPU, pick the memory, and that's adjustable. So if I change my mind down the road, it is possible to adjust the amount of capacity allocated to a particular compute resource. So we're scaling up or we're scaling down. Thus, we're not over provisioning, we're not leaving idle resources lying around, and we're basically able to control costs more effectively. There is this notion of, yeah, go ahead, Larry.
Yeah, that cost piece there, that's a piece that it's a crucial piece that we need to talk about too, because in the beginning we're talking about cloud native and going to cloud native resources, going to all utilizing these, being able to use burstable reservations. But I think cost is something that is important to discuss, because you can basically look at what you have on-prem and match it here, and you're going to be maybe spending too much, and that's where the monitoring and all of the other pieces, when you're talking about, oh, these are adjustable, you can dial them down, and you can make changes to which processor you're using based on what you're trying to do. You can make changes to the services you're using. So there is a way to reduce the cost but still get great performance. And I think that's something that there's a lot of tools to kind of monitor that inside the console as well.
That's a great point, Larry. And I was actually just reading a report not too long ago about 32% of cloud spend in 2022 was essentially wasted. So over provisioning resources or spinning up resources and not going back to trim them down. So we're really big on making sure that that doesn't happen in Oracle, whether it's using these flexible shapes, whether it's using various cost analysis and monitoring tools to ensure that you're able to adhere to given budgets and whatnot. But again, that those costs can sneak up on you if you're not careful. Shoot. And we just want to make sure that that's considered as part of this build and deploy for your application ecosystem.
Eli, but going back to like the point of, there are tools in the console. So Cloud Advisor is going to show you some of your of unutilized resources, and so that's a good thing to take a look at, and just kind of monitoring what the application's actually doing. Because a lot of times when you look at your databases, is that database being utilized? Can it be just stopped or turned off? Or, well, in some cases, to save costs, you actually need to bring the data out of it and actually delete the database. And I think when we talk later, when you get into like Terraform and some of the other tools, that's where it's a good idea of like, hey, if you're not using that database for months on end, may as well delete it and just have the data there that you can reload if you need to access it. So there's lots of ways to kind of look at that to save some money.
Yeah, take a snapshot, which is stored in a much more cost-effective manner, and then just toss the database service, come back later, restore the snapshot, and you're back up and running. It's a great point,
Exactly.
Larry. All right, I want to talk about cloud-native apps. So this is another kind of design consideration. We're thinking about, performance, availability, cost, reliability, and of course, control versus agility. It's kind of the key point here. When we're talking compute, my touchpad is very, very touchy today. I apologize. Full control. We can spin up a bare metal machine. You can install your own hypervisor if you want to. You can install as much custom software on the bare metal machine as you want. But again, you're paying for the whole thing, all the underlying physical hardware. So maybe a virtual machine with flexible infrastructure is a bit more appropriate. We'll kind of evolve from there into containerized applications where we can leverage two layers with A, the underlying compute, which is flexible, and B, the container environment where we're deploying small quantities or small units of work that allow us to kind of stack and pack the resources, the physical infrastructure better, and scale in a much more granular fashion. So we'll get into the Kubernetes piece in a couple of sessions down the road, but I just wanted to kind of tee this up here for consideration before we go any further. And of course, serverless functions, that is, build a simple container image with some code, give it to our system, and then the system runs the code on demand. And basically, you're paying by the millisecond. There's no other infrastructure cost associated. So more to come on that. Our managed Kubernetes service, OKE, is built on open standards. This is full open source Kubernetes, just like everybody else is using. It's built into the Oracle ecosystem. So it's a fully managed control plane, data plane with automated scaling capabilities, automated update capabilities, and tight integration with not only the security platform, but also the rest of the OCI services. So we'll look at, again, down the road, using some of the service operators where you can actually provision OCI resources through Kubernetes. So if you're familiar with Kubernetes and you're using it either on-prem or other cloud providers today, it's just a matter of writing a manifest file with the service definitions. Once you've deployed the service operator, you apply that manifest, and Kubernetes and the integration takes care of spinning up the additional resources. So it's pretty slick, pretty cool. And just to kind of illustrate that integration here, the Kubernetes piece, the control plane, is fully deployed and managed by OCI. There's the underlying data plane where you deploy your nodes or your serverless virtual nodes, and then you can attach whatever types of storage you want to use. You can integrate with database, with DevOps, other open source tools, governance, encryption, and so on down the line. So a lot of different design considerations and capabilities to leverage that, again, will help kind of offload your administrative tasks, allowing you to focus more time on building high quality, effective applications. Right. So wanted to spend just a minute about data, right? We talked about the data considerations earlier, and as modern applications continue to grow and evolve, there's different data types. We started out with relational databases way back in the day, and I actually worked with Oracle Database 7i, which I think was released in 1997. That was my first exposure to Oracle a long time ago, and it's just been evolving nonstop from there with JSON databases, MongoDB and others coming out more than a decade ago. Moving into some of the like the AIML stuff, machine learning, graph databases, data lakehouses, blockchain, and it can become rather cumbersome trying to think about what is the best tool or service I'm going to use for this. So maybe speaking from my own experience, I've used Microsoft SQL in the past for relational. I've used Mongo for DocumentDB. I've used some other cloud provider services for GraphQL and for spatial databases, and trying to think about the different tools and components and manageability, it becomes a little cumbersome. So Oracle spent a lot of time really delving into this and trying to find a way to simplify the entire data platform, being able to provide a converged database that gives you all of those services, those capabilities, without having to think about a different set of APIs or a different set of configuration and deployment controls. Rather, I deploy a database, and then how I interact with the database defines how that database actually stores and manages and computes the data for me. So that, just to kind of show what that looks like here, with Oracle 23c, your SQL statement essentially defines what and how you're interacting, whether it's JSON documents, whether you're doing graph analytics, fuzzy text searches, XML, and so on down the line there. And then the types of data you're storing are handled by the database in the most appropriate and performant fashion. So it kind of takes away from that, how do I deploy and tune the right database or the right service for the types of data I'm working with, and simplifies it around the single converged database. And then just really quick on the autonomous database. So full integration, again, with the OCI Cloud. We want to make it as easy as possible to deploy and leverage this. So whether you're using the traditional N-tier applications like we're talking about today, whether you're using full containerized microservices, there are tools and integrations built and available in the Oracle Cloud to make it as seamless as possible to deploy, manage, and integrate with the autonomous database service. Larry, any other thoughts from you on the database front?
It's something that there's a lot of different database options, as you stated, and I think that's it's one that you have to sit down and hope you pick the right one. Oh, no, it's more than that. There's a lot to the database and making sure that and we have a lot of options in the console.
Right.
So I don't have a lot of points on that one. I think it's looking at what you're going to use, how it's connected, how you're accessing it, how can it scale. And I think that's the other piece, is making sure that it can scale appropriately for what your application is doing. Because one of the databases, one of the things that I worked on in the past, it didn't need to have a bunch of write capacity. It had to have a bunch of read capacity because the data was loaded every day for pulling out a material list, and that was the price sheet for that day. So you just had to have a bunch of read replication. So depending on what you're doing, lots of options there.
Definitely. That's funny. I was chatting with a customer not long ago, and they brought up a like 2-page flow chart that another provider had given them of how to choose the right database. And it was literally a 45-minute to an hour exercise to pick the right database based on the workload. And I thought, or you could just use one database and call it a day. So, all right.
Exactly.
I want to talk just briefly, again, I mentioned low code earlier, and this is a little bit outside of my area of expertise, but it is a dominating factor in cloud. And I'll show a demo of a low-code app. Actually, some of you might have already used it. But Apex gives you the ability to basically stand up and deploy apps quickly with tight database integration to provide visualization, to provide automated tasks for analytics and other capabilities, all built into kind of one tight-knit ecosystem. And the 20 times faster with 100 times less code is actually not too far-fetched. So if you get a chance to poke it at Apex, it is a pretty interesting tool. It has a nice WYSIWYG editor, and then you choose how fancy you want to go. There's a lot of built-in workflow and capabilities where you simply just click and configure, with the capability to write fully functional code to drive additional capabilities inside the application itself. So I will share. Yeah, go ahead.
I was going to say on Apex, I mean, it's a really versatile tool, because we've been able to, for my team alone, been able to use it to pretty much manage every aspect of our training and our data tracking for what we do. So it's got a lot of capabilities to build out. You can have a calendar, and then you can have spreadsheets, and then you can have pretty much any aspect built out that you need to manage your day-to-day operations as well.
Absolutely. And the cool thing is, if you deploy an autonomous database, there's a button in the console that says Open Apex, and it launches an Apex instance that sits right on top of that autonomous database and lets you kind of build and tune and configure whatever it is that you want to do with that application. I found it's great as well for folks who maybe are newer to the app dev space, or maybe transitioning from a non-app dev role and wanting to pick up some new skills. It doesn't take as much time and effort to learn Apex as it would maybe Java, Python, more traditional development languages. So that's another avenue for folks. Wanted to share this, and we'll send the slides out so you'll have this QR code later, but a colleague of mine coming up in a couple of weeks is doing a live workshop building a starter app with Apex, which is super cool. It literally, you can build the app in 60 minutes and an experiment and kind of poke around at the functionality. So if you're curious or interested in that, please sign up and come take a look. All right, kind of the final preview, I guess. And as I mentioned, the 6th and final part of the series is going to be on DevOps. But I did want to talk just briefly about OCI Devops and how this is, a tool we introduced to the a tool that we introduced to the ecosystem a couple of years back, not necessarily to replace anything. If you're running Jenkins, you're running Spinnaker, you're running GitLab, any other CI/CD tool today, this isn't really intended to supplant that. The idea is, how do we take what you're doing today and integrate that more tightly into the OCI ecosystem? So OCI Devops gives you that built-in integration to the entire Oracle Cloud. It gives you the security that's baked into the rest of the ecosystem, and the ability to simply plug in where you need and to do what you need with. as an example, this would be, I'm running Jenkins already. I use Jenkins for build tests and integration, some basic, lint checking and code validation. And it's also producing my Docker image, right? But from there, maybe I'm using OCI and a number of other cloud providers. And it doesn't make sense to have Jenkins do all of the deployment for me. What I can do is actually have Jenkins push that artifact to the container registry in OCI and maybe the container registry and other cloud providers and trigger the deployment pipeline. So we're going to leverage the functionality built right into OCI to deploy to Kubernetes or deploy to a virtual machine or a set of virtual machine hosts, and utilize approvals and other testing capabilities in OCI specifically that are already baked in. I don't have to build or code those capabilities into Jenkins, which would be additional overhead management expertise. I could simply leverage what's already there in OCI. And this kind of, again, going back to that multi-cloud flexibility, leverage the tools you have, but also take advantage of some of the tight-knit integrations that exist in the ecosystem. Session 6, we're going to spend a full hour talking about CI/CD. So hopefully you can come back and join us for that. Fun stuff. All right. So finally, I just wanted to show, again, the app ecosystem here. We're kind of starting at the foundational layer here, the compute, storage, networking. Again, when I started at OCI, that was kind of it: compute, storage, networking, and database. And to see this ecosystem just explode over the last handful of years to this, fully capable, fully built app ecosystem, very open source friendly. So, one of the benefits to a lot of the OCI managed services is they're based on open source. They're not sticky services. They're not going to be somewhere where you put your application or you put your code or you put your data and you're stuck. It's very easy. It's portable. I can take those container images and deploy them to other cloud providers. I can take my MySQL database, do a dump, and deploy it to a different, my laptop on-prem, different cloud provider. So the notion is we're not trying to establish any sort of lock-in here. It's open, it's easy, and you can leverage the existing set of tools that you're already hopefully utilizing. Larry, any parting thoughts from you before we move on to the demo?
I think we covered some of the good points. Security was one of the first points that we hit on for cloud native, because even with building out cloud native, you still have to think about it. Cost savings, one of the pieces where you're talking about, like, hey, if you need to take some of your stuff out of the cloud, put it back onto your local system, local server, we don't charge you until you hit, 10 terabytes a month, something like that for
outbound
export.
data.
Yeah, so it's there's a lot of things that you can actually do here that are going to save your costs, especially if you're using the cloud native services, monitoring those, because a lot of the tools, like security side are included. They're not something that we're charging you for those services because we want you to use them. So there's lots of options when you start building out your application on OCI.
Excellent. Thanks, Larry. All righty. So we have a workshop that's going to take place after. Just a quick overview. We're going to be deploying a virtual cloud network with some resources. We'll deploy a virtual machine for WordPress. We'll deploy a MySQL database on the back end, and then set it up, get it running, and see how it goes. All right. My handy dandy OCI Cloud Console. Couple things I have I'd just like to point out, and we're going to cover these in session 3, but the CloudShell, the code editor, we're going to go into a lot more detail. But for the purpose of this demo, I've actually got these both running. And you can see here my code editor, it looks a lot like VS Code. If I were to change the file extension, it would do all the fancy formatting and coloring for me. Integrations with GitHub and other source control tools and OCI services. But that's not what we're here to talk about just yet. CloudShell gives me a nice little terminal interface. It's a fully managed terminal that's inside of OCI. So the default is public, But if I wanted to, I could actually insert CloudShell into my private virtual cloud network. So I have a VCN that I've built. I have a private subnet that has no access to or from the internet. And essentially what that's a virtual network interface card. That's fine. And the VNIC is going to sit inside of that private subnet. So I can access resources that are not accessible from the public internet. If we go take a look at an instance here just real fast. And this for me, if I'm troubleshooting, if I'm trying to figure out what's going on with an application I've deployed in a private secure subnet, this is the fastest way in, aside from, well, faster even still than deploying a Bastion server or using the Bastion service. So I can grab the private IP address. Let's see. Grab my key, and then we're just going to log in and poke around a little bit. So Apache's running. This is my demo server. This is what you'll build in the workshop. But that's kind of the cool thing there. And now I'm actually, again, connecting privately inside of that subnet as opposed to, across the public internet. So the workshop that we're going to do, actually, we're going to start with the network. And I'll just walk you through this here really quick. I've already built everything just because it's a live demo and you want to have backup options. Just like deploying production workloads, you've got to have some fault tolerance and some resiliency. But you're going to build a VCN. In this case, I called it Cloud Coaching Demo. If we use the VCN wizard, it's going to ask us a really couple simple questions. Look at that. I have a lot of VCNs running in my account. That just means I've got to go clean things up later. So we'll call this sample app. I'm going to assign a VCN CIDR block. So this is just a private 10.0 range. You can assign IPv6 if you'd like. Once you assign IPv6 to a virtual cloud network, you cannot remove it. Just as an FYI. We're going to create a public subnet and a private subnet. That just means anything in the public subnet with the appropriate route configuration can access to and from the internet. Anything in a private subnet, that's just an extra wall. So we're designing around access to those resources to and from the public internet. They're blocked off. You have to kind of go out of your way to access them. We get the summary, we'll hit create, and it spins up the resources for us. Now, given I already have one, I'm not going to go through the process, but you'll see here, it creates the VCN, it creates two subnets, some gateways, internet gateway, just like it sounds. The NAT gateway is going to give us network address translation. So this is one of the mechanisms we could use to access the internet from our private subnet. So think, yum update from an application host in a private subnet. I need to go out to the internet, get the Linux repositories to download those updates, and so on. Security lists allow us to define ingress and egress rules. So what type of traffic is allowed into or out of our subnets. And the route tables just talk about the next hop. So if I need to go to the internet, my next hop is my internet gateway. If I'm going to the internet from a private subnet, my next hop is the NAT gateway. If I'm accessing an on-prem environment, my next hop is probably my dynamic routing gateway, and so on. All right, got my VCN. Next thing we're going to do in the workshop is create a MySQL database service. This is a fully managed MySQL server. So we take care of all of the administration, patching, etc. And what you can also do here is kind of decide, is this for development and testing, where we need, production, we need high availability. I need a cluster, multiple SQL servers, that in case one does fail or go down, there's no data loss. Or I'm just testing, I don't need to spend a whole ton of money here. Oops, sample app. So single standalone DB system. This again, it's not highly available, it's not fault tolerant, but it is going to give me the functionality I need. We'll give it a username and password. And I'm just going to make this up because we're not going to actually create this here. I've already got one. And we're going to pick the network. So where will we deploy this? It's a database. I don't want this exposed to the internet, so I'll pick my private subnet. And the shape. In this case, it's dev. I don't need a whole ton of capacity. So let's just go with the option selected. It's a single OCPU with 8 gigs of RAM. That's more than enough. Data storage, 50 gigabytes is plenty for my sample app. I'm going to go ahead, because it's not production, I don't need backups. So we'll save a little bit of money there with automated backups. We just hit create. It's going to take a couple minutes to spin up the resource, and it's going to give us essentially this. Now, my endpoint, in this case, is a private IP address in that private subnet, accessible on port 3306, which is standard for MySQL. If I had read replicas, if I had HeatWave, which is an in-memory query accelerator enabled, those configuration options are visible here, any backups that have been taken, and so on. But really all I care about are the username and password that I set and the IP address of that host. So if I wanted to go take a look, I'm in my ephemeral private network still. Let's just zoom in a little bit more. And I've already forgotten the IP address. .1.80. 180. Oh, sorry, wrong server. There we go. I was in the app server, and I don't have MySQL installed there. Admin. Okay. Voila. So I can poke around, see my databases, and do all my MySQL stuff here. And again, that database is not accessible outside of this private subnet. Next thing we're going to do is go over to the compute area here. We're going to deploy a compute instance. So I have one running here, but basis of this is to give it a name. Pick our image type and shape. Now this is where that flexible infrastructure comes into play. If you're running the E4, E3, or E5 flex shapes, you'll see the capacity that I have available to me: 114 OCPUs and 1.7 terabytes of RAM. And it's just a matter of picking. Yeah, let's do 49 OCPU. No, my boss might have words with me on that. But here I could go just one OCPU, and I can go up to 64 gig of RAM if I needed to. Or if I need more compute capacity, but not a whole lot of RAM, I can scale that back. 8 OCPU, 8 gig of RAM, that's plenty based on my app requirements.
One of the things, on the OCPU and the type, one of the things you can actually do here to prevent random launches of large instances is using quota policies inside the account.
That's a great point, Larry. You can define quotas by tenancy and by compartment to say, here's the shapes and sizes you can provision. Anything else gets automatically blocked. All right. Now, I think I have to zoom. Oh, no. Okay. We'll pick our shape. We're going to pick our network here. So the VCN, this is going to be a public-facing web server. So we'll want to make sure it's in the public subnet. It will automatically assign a public IPv4 address that is accessible from the internet. And in this case, we can either generate a key pair. So if we want to SSH, which we do, we'll generate the key pair. Make sure you download the private key. I typically download the private and the public key. So if you plan to use that key pair elsewhere, if you want to provision new servers with the same key pair, making it easier to maintain and manage your access, you'll use that public key pair. You'll just upload that later when you launch new servers. What that looks like is copying that pub key, dropping it on the field here, and it just shows up like that. All right, the last thing, and I just wanted to show this as a shortcut. So the lab doesn't walk you through this. Consider it a challenge round. There's this Cloud Init script, and this will run basically at console when the machine bootstraps, so you can add additional configuration while the system's spinning up. And this is beneficial if you're leveraging things like instance pools and auto-scaling groups, so that when you need more capacity automatically, you could add new servers and they're configured on the fly when they're provisioned. And this is basically just a shell script. And again, it runs as root, so you don't need to use sudo when you write your commands. But what I have is a script, and I won't show the whole thing. Maybe I will. Basically, I took all the steps in the lab and I wrote a script for the set of commands with a few minor tweaks because certain commands don't run at console, at Bootstrap. You got to tweak them a little bit. Script that essentially auto provisions the entire machine for me versus logging into the thing via SSH and doing the configuration by hand. There we go. So start our shell script as we always do. We're going to install Apache, and this is the lab steps actually broken down into a script. So you'll install Apache, configure the firewall D service. So we've got to add HTTP to allow ingress on port 80. We'll install PHP, create a very basic PHP script for testing purposes. We'll install WordPress. And this is not recommended, but done solely for the purpose of this demo. You'll see my password there in plain text. Typically, you'd want to, use a secrets manager to store that in encrypted fashion. You could retrieve the encrypted value in the basically in memory temporarily and pass that to your SQL login for the purpose of then creating your WordPress database, creating the WordPress user, and then assigning permissions to that user. So what that would wind up giving me at the end is a server that is accessible. Oh, I think I have to zoom out. There we go. I have info.php. So that's the very basic info.php file that we create as part of the process just for testing purposes. This is to make sure Apache and PHP are up and running, or I just go to the root of the server, and now we're at WordPress. So we're going to start the configuration process. We'll give it the database name, username, password, that, in this case, 80, and so on. Hit submit. It's going to configure WordPress for us, and we'll be off and running. So it's going to be essentially running on this compute instance in the public subnet. It's going to be leveraging that MySQL managed database service in the private subnet, and everything's good to go. So that's kind of what I have. I think Renu put the link in the chat for folks that want to take it away and get started. Are there any questions? I'll pause here for a second. I'm going to go back to my slide deck because I do have a couple more QR codes to share with folks. We have my team runs a public Slack workspace. If you want to join us there's channels for Python and Java and DevOps and infrastructure as code and all kinds of fun stuff. Come hang out, chat with us, ask us questions. We also run the developer.oracle.com website with tons of tutorials and announcements, product features, and really cool workshops and whatnot there. And last but not least, some additional links, upcoming events, and Oracle free trial, if you want to give it a shot. I did mention earlier, so low code, Oracle Apex. This Live Labs system here is built on Apex. All the cool stuff you get to see, all the hands-on labs that we publish and make available, and by we, I mean all of Oracle, not just my team, broken down by your role, whether you're a developer, a DevOps engineer, SRE, low-code developers. You can come in here and see a whole list of workshops that are available just beyond the one that we're going to do today. And we're going to do a handful of workshops throughout this entire series. So check back and, we're going to dig into, as I mentioned, infrastructure as code. We'll dig into containerization, serverless functions, and at the end, that DevOps piece. I'll say one last call and Renu, back to you.
Thank you, Eli. Thank you, Larry. Great session. I hope everyone enjoyed the session and learned something new today.
And just really quick, so the map that I had earlier on the screen is from the original Final Fantasy video game from the Nintendo Entertainment System, released in 1986, I think, or 85. Yes, very old school.
For any questions from today's session or anything related to Oracle Cloud, you can email us at personaltrainers_us@oracle.com. Thank you so much again. Thanks again for joining us, everyone. See you all next time. Have a great day, everyone.
Thanks, everybody. Take care. Good to see you.